Okay, so in this video, I am going to show you how to conduct a regression with a categorical predictor. So first I want to open up the data set that we've been using in these videos and show you what I mean by a categorical predictor. So a categorical variable, the values under it, I say values, the data under it is not values, it's category names, group names. So this function variable here, sales, you can use the filter to see what the different functions are, finance, HR, marketing, and sales. So those are categories, right? That's a categorical variable. How can we use regression to see, does function affect happiness or anything else? So there is a way to do this. There is a way to transform a categorical variable into a quantitative variable. Now, keep in mind, this is not ordinal data. So these categories cannot be placed in order from smallest to largest. So it is not appropriate to just assign each one a different number under this column. For instance, sales is 1, finance is 2, HR is 3. That is not appropriate because this is not ordinal data. What is appropriate is to use a process called dummy coding. So we're going to talk about regression with dummy coding. So like I said, a regression can be used with categorical data if the data is recoded to numbers. Now, the way that we're going to do this is we're going to create a new column for each group. If that row of data belongs to a person, place, or thing in that group, they're going to receive a 1 on this new column. If they do not belong to that group, they're going to receive a 0. Okay? Some advantages to this process. You can pull all of your variables in to a multiple regression as predictors. All of your functions, all of your survey data, whatever. You can put everything in as a predictor in a multiple regression and test a complex model with just one test, which is really the appropriate thing to do in many cases. You can also use the line equation to predict our dependent variable using those dummy codes. A disadvantage of this, it doesn't give you as much information like some descriptive statistics like some other tests would, but it will tell you if there is a relationship between the variables and it will allow you to predict. So that's a big advantage. Also, because of redundancy of information, what you're going to do whenever you run your regression is you're going to leave one category out. So for instance, the function data, there are 4 categories: finance, HR, marketing, sales. You're actually going to only do 3 of them. Leave one out. It doesn't really matter which one. And the reason why is because if someone has a 0 on the other 3, then they are in that 4th group. So it's like duplicate information, basically, if you have the 4th column there. And what will happen is you'll get an NA or some kind of error in Excel. So let me show you how to dummy code the function variables, and you can see what I mean by all this. So here is our data set. To dummy code, I like to put the columns right next to function. Like I said, you only really need to do 3 of them, so don't waste your time and do all 4. We're going to do sales, finance, and HR. We'll leave out marketing. So so here's a person in marketing, they're going to get 0, 0, 0. So you automatically know that if someone has a 0, 0, 0, they're in marketing. So we don't need another column. Okay, so the fastest way to do this is to use the if function. Now you can also just use your filters if you want to just filter in sales and put 1s, etc. I like to use the if function. So if, open parentheses, this equals, in quotes, sales, comma 1, comma 0. That's telling Excel if, let me go back to the function, if this cell right here equals sales, comma, give them a 1. If not, give them a 0. We're going to drag that down, drag it all the way down. Okay. Another thing that I like to do is I like to remove the function behind the value once the function has done its job. So if we were to move this column around for some reason or delete columns or whatever, then our formula here is going to get messed up. So in order to stop that from happening and make all your numbers stick, you're going to copy this whole column. So I hovered over C, select the whole column, do copy, and then in that space, I'm going to right click and do paste 1, 2, 3, which on a Mac, it's going to be paste special values. Then I'm going to do the same exact steps here. So for finance, I'm going to do equals, open parentheses. If this equals finance, and make sure you don't have any typos, comma 1, comma 0. I'd highly recommend doing this pausing this video and doing this on your own, and making sure everything is working out. And then finally here, if this equals HR, see if that works, and just kind of spot check it. I like to scroll down and just kind of make sure it filled all the way in. This is a pretty big data set, down into the 600s. So just make sure it went all the way down and just kind of spot check. I'm seeing ones in this column for finance, ones in this column for sales, ones in this for HR. Marketing has all zeros. Just spot check a few of them. And then, like I said, wipe out those functions, make the values stick with doing the copy paste 1, 2, 3. So that's dummy coding, and I don't have in the slides that you need to run a regression, but I can just quickly show you. So data analysis, regression, you're going through the same type of thing. For your X input, you're going to highlight these columns together. Everything else would be the same. And then you're going to see your results here. So this was not a significant model. You can look at this p-value here. It's 0.51. And from the t-tests, all of these p-values are more than 0.05. So we can conclude here, function was not a predictor of happiness. The last thing I want to show you for now with regression is talking about error with regression. So there are some things to look out for. First of all, you want to make sure you have a large enough sample size. Back in QBA, I know you learned about the magic rule of the magic number of 30 for sample size. 30 is really small. In practice, a lot of you are going to have access to data sets that are in the thousands. So hopefully this won't be much of an issue. But if you're working with a small data set, one rule is you need to have at least 10 cases per predictor, but that is, really small. I would try to have many more than that. The other thing I want you to keep in mind, alpha. So we've talked a little bit about alpha, our p-value. Our p-value needs to be less than alpha to tell us if there's a significant relationship. What is this alpha? Alpha, remember, is your chance of making a type 1 error. A type 1 error is whenever you conclude there's a significant relationship, but there's really not. So if alpha is 0.05, you have a 5% chance of incorrectly concluding that there's a significant relationship. So what is your chance of error if you run 10 regressions? So if you have 5% per regression and you do 10 regressions, you have a 50% chance of error. That's not good. Half of your findings are probably incorrect. So what do you do about this? Include all of your predictors in one multiple regression. Then you just have a 5% chance of error. That's it. So you want to do just one really big multiple regression. That's better than doing a bunch of small, simple linear regressions where you have 5% chance of error every single time. Another thing you could do, if for some reason you did do a bunch of simple linear regressions, you could do something called Bonferroni's correction, which is where you divide alpha by the number of tests that you did and then use that as alpha. So you'll probably end up with a much, much smaller alpha. Not as many significant findings, but less error. Okay, so that concludes the videos on regression. I do, though, want to revisit this decision tree. Regression was over here. So what kind of variables do you have? Typically, your independent variable and dependent variable is at least ordinal. You want to test whether the independent variable predicts the dependent variable. If you have one independent variable, you're going to do simple linear regression. If you have multiple predictors, you're going to do the multiple regression. But all of this really can be done using regression as well. So we talked about dummy coding. If your independent variable is nominal, create those new dummy coded columns and you can do a multiple regression. So yeah, that concludes regression.